All right, now let's have some fun with simulations and try to understand the principles of system design or process design using simulations. So I have a system where I've created a uniform, a stable system. There's no variability at all. This is hypothetical. Real life, it's almost impossible to not have variability. So it's exactly minimum is 100, maximum is 100. So this means that the times will only be 100. Service time is only 100 minutes. So, you see a uniformity if you look at the sheet here. The first customer comes at 100, services finishes at 200, the second customer comes at 200, service finishes at 300, and so on. And what happens is every time nobody has to wait, customer is served immediately, server is rarely idle, and the world lives on happily ever after. Now, as we know, such hypothetical systems rarely exist. There's always some variation. So let's build in some variation, all right? So I'm going to say now my variation varies between 90 and 110. So what happens is the average is still 100, right? And if I simulate the inter-arrival time, you'll see that the simulated average is also close to 100. So simulated average is close to the planned average. All right, so it's okay. So now what I'm going to do is I'm going to simulate this 110 times and find the grand means to find what's happening when there is variability. So Excel is doing this. It takes time, maybe a couple of seconds, but yeah, it's completed. So what we find suddenly is that from zero waiting, we go to 62 minutes of waiting on an average for a system with this kind of behavior, which waiting is 90 to 110. Now let's suppose the waiting goes on to 80 to 120. All right, it goes increases, the waiting increases. So if I just simulate this, you see that again, the simulated average is 100, which is close to this number, which is fair. Let's find the averages. Excel is working and doing its job. Yeah, and we get 140. So if you look at it, what happened is from 60s, it has gone up to hundreds. Okay, when I increase this to 80 to 120. If I increase this further to, let's say, 60 to 140, average is still 100. You can simulate inter-arrival times to find that, well, this is in fact lesser. Wonderful. But yeah, if I do this, what you'll see is the waiting time goes up substantially to 200, 238, 240-ish kind of levels. So what we're coming here is this first principle, that for any given service rate, as the customer variability increases, the average wait time also increases. Okay, so even if I am providing the same level of service, same rate of service, as the customer variability increases, my customer wait time and hence my customer dissatisfaction and hence my revenue can go down. Now, I've just done here, I've assumed service time is uniform. Go ahead, use the sheet and try to vary the service times and see how crazy these wait times and the utilizations get. So all I'm going to do is I'm just going to do one thing. I'm going to change this to, let's say, 80 to 120. So the average still remains as 100. Let's see if the simulated averages are common. Yeah, simulated averages are common. Arrival time is lesser a little bit. But when I find the averages 10 times, what we found is it goes up substantially higher to 133 minutes. It's about the same. But again, go ahead, experiment with this, find out how it works, and try to see how you can use this principle number one.